Alright, so we're going to go ahead and begin. We're going to review real quick on the things that we have covered before. One of the things that we have covered before was actually understanding the sum of an angle of, let's say, 1, 2, 3, 4, 5, 6, 7, and 8. If we add angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 plus angle 6 plus angle 7 plus angle 8, what will be the sum of all those angles? What was the trick that I told you guys to do to help you solve the sum of all of these angles? Alright, he said n minus 2 and then multiply it by 180. That is the equation. Okay? However, I also told you guys, what happens if you forget the equation? What else can you guys do? What happens if you forget this equation, 180 times n minus 2? How can you guys find the sum of all of these angles over here? Yes? Count how many triangles are inside the figure. For that, you have to get one of the vertices. It doesn't matter where the vertices is at. I'll pick this one over here. Remember, if I make a line going this way, it overlaps, so I do not go in that direction. So I could make a line going here. That's one triangle. I'll make another one going here. That's a second triangle. That's the third triangle. That's the fourth triangle. That's the fifth one and the sixth one. So in this shape, there are 6 triangles. And what we do with those 6 triangles is multiply 6 triangles multiplied by 180 degrees. What's 6 times 180? 1080 degrees. Alright? 6 times 180 is 1080 degrees. Now, another thing we could do is this, that I went ahead and showed you guys last class, was if I use the word, because this right here, what type of shape is this called here? Octagon. It's an octagon. Correct? If you have the word regular in the front of octagon, what does the word regular mean? That what? Anyone?
The sides are equal.
Alright, the sides are equal. Anything else? Anyone? What are these things called?
Vertices.
Vertices, or what? All the angles are congruent. What does congruent mean? The same. So, keyword guys, congruent means the same. So, if all the angles are congruent, and now the question says, what is the measurement of one angle of the octagon? What should we do next? Uh-huh. Very good. Divide what by 8?
1080.
Very good. if we know the sum of all of these is 1080 degrees, then we could take 1080 degrees and divide it by 8 because it has 8 what? 8 angles, right? So we'll take 1080 degrees divided by 8. What does that give you?
135.
100 and what?
35.
So each angle, guys, is equal to 135 degrees. Any questions? All right, so this is part of the review. We're going to go ahead and add on to this now even more. So for today's lesson, we're going to go ahead and I'm going to show you guys a new topic. The new topic is found actually, I believe, in lesson 5.6. I believe. Lesson 5.6. All right. In lesson 5.6, it deals with it's called the Pythagorean theorem. The Pythagorean theorem was developed by a mathematician named Pythagoras. All right. Basically, what Pythagoras says was this: that for any right triangle, let me go ahead and show you now. That for any right triangle, keep in mind something. This is important here. Please pay attention. For any right triangle, is this a right triangle? Yes or no?
Yes.
Yes. Is that a right triangle? Yes. For any right triangle, if you're given two sides, then you can always find the third. I repeat, if you're given two sides, any of the sides, you can always find the third side. So his the Pythagoras theorem is actually a squared plus b squared is equal to c squared. All right, but you need to understand what is a, what is b, and what is c. So in order for you to do this, let's analyze the right triangle. Notice where the 90 degree is at, right? You guys see the 90 degrees right here? The ones that are next to the 90 degrees, the legs, these are called the legs. All right, let's go ahead and put legs here. Legs, a leg, and a leg. So automatically, you should know what the legs are at. The legs are always right next to the 90 degrees. We understand that, yes or no? All right. If these two are the legs, the longest side, that is called the hypotenuse. The hypotenuse. Okay? That's called a hypotenuse. Now, again, if you look at this here, guys, you guys see this right here? Again, what is this side called?
Right.
Your leg. And what is this side called? All right? Those two are your legs. Now, if those two are your legs, what is this side called over here? The what? Very good. I'll go ahead and abbreviate it. Now, in order for us to use this formula here, A and B are going to be your legs. C is going to be your hypotenuse. Do you guys understand that? So the very first thing that you guys have to understand when you guys use the Pythagorean theorem is what is A, what is B, and what is C. So let's go ahead and do an example right now. All right? This is an example. This is actually a special right triangle, but if I give you this to be 3 and I give you this to be 4, and I need to solve for x, okay? Can I use the Pythagorean theorem to solve for x? What is the answer? Yes or no? The answer is yes. Do we have at least two sides? Then we could solve the third side. Again, if we have two sides, we could solve for the third side. So let's go ahead and work this out. So according to this, guys, let's pay attention. We have a squared plus b squared is equal to c squared. We're good? All right, the question is this now. What is a and what is b?
11. I mean, but it's.
Can a be 3?
Does it matter the order?
Does it matter? Yes or no?
I don't think so.
Why not?
Because they're both.
What math property are we doing here? Yes, it is addition, but what math property is this? Begins with C.
Commutative.
Correct. The commutative property of addition, right? Why? Because what is 3 plus 4? What's 4 plus 3? It doesn't matter which one you really put as A or B. As long as we know, is 3 a leg, yes or no? Yes. Is 4 a leg, yes or no? Yes. So look up here. My legs are what? My A and B, right? So I'm going to go ahead and plug them in. This is 3 squared plus 4 squared is equal to C squared. Remember, guys, that we're working going down. All right?
Staff members